hello. Okay, picking up where we left off. Last time I had a bunch of questions, and so I have some answers, and the rest of them we'll just have to figure out together. So the thing we did last time was start to implement tensors, so that our input, which used to be 2D, where one axis is the actual sample that we're working on, and the other axis is a batch axis, so we're basically doing multiple samples at the same time. We were changing that so that our sample itself is 2D, and the batch axis makes the whole thing 3D. So a tensor is the general name for the thing you get when you make a matrix but have more than 2 dimensions. And there was some stuff I didn't understand and some stuff that wasn't working, and so here's what I figured out in between streams. So why am I generating 1 token per input token? That was something I was trying to figure out. So if you look at the transformer, the input is 3D, where one axis, for me, one axis is the letters, one axis, one axis tells you which letter you're talking about. Another axis is to have multiple letters in the input, which obviously you need if your prompt is a sentence. And then the third axis is a batch, so you could have multiple examples at the same time. So the thing that was confusing me is the input is 3D, the output's also going to be 3D. How do we get a single token prediction out of that, or a single letter prediction? So it seems like what's happening is I'm predicting 1 token per input token. And I didn't get that. I was like, shouldn't I only be predicting 1 token total? So the answer is yes, I was understanding it right. The output is 3D. And then the softmax is going to apply to the 3D output so that for each batch you get 1 letter per letter in your output. Why do I care about generating all of these letters? So there's a difference between training time and inference time. Inference time is like when you're actually using the trained model. When you're using the trained model, you don't care about all of the extra tokens. You only care about the last one. But when you're training, you can actually use the intermediate tokens as predictions from that like from that time. That's a crazy way to say that, but it's like if I have this sentence, hello, I'm Cloud. I could say that the predicted letters for each letter should be, or let me not put a period there. The predicted letters for the predicted output for this should be this. So the predicted next token for H should be E, predicted next token for E should be L, etc. And then the predicted next token at the end should be period. There's some weird stuff about this that I don't really get. So like explaining this right now, here's the thing that makes sense to me and here's the thing that makes no sense to me. So the thing that makes sense is you're getting more training out of a single sample because you're predicting like from here you're predicting this and from here you're predicting this. So you're getting, if my number of characters in the input is 10, I'm getting 10 training samples per sample, in a way. So in that sense, it makes a bit of sense to me. There's another sense in which it makes no sense at all, because the attention mechanism has access to the other letters in the sentence. So couldn't it just look forwards and like, couldn't it just like look at the input and figure out what the prediction for this letter should be? Now that I'm saying that, I'm wondering if I've been missing an important detail this whole time, which is the masked part of the masked multi-headed attention. So the mask is supposed to prevent you from looking forwards. And I think I was just missing that this whole time, because here there's no mask, and this is what I was thinking of implementing. In the decoder-only transformer, which is what I'm doing, masked self-attention is nothing more than sequence padding. The masking term is a leftover from the original encoder-decoder transformer module, in which the encoder could see the whole original language sentence and the decoder could only see the first part of the sentence, which was already translated. Okay. So I actually am not sure that this is right. Excuse me. Okay, basically I'm confused. I'm gonna delete these. Oh, okay, well, okay, the answer to this is, why am I generating one token per input token? That's naturally the shape that the output is gonna have, but it's not necessarily bad because you can use the tokens to help training. And then how do I do backprop when I only care about the last token? The answer is start caring about every token. Treat them as predictions as well. So I'm going to delete these. I have a new question, which is, do you need masking in a decoder only transformer? If no, why doesn't it learn to look ahead to predict tokens to predict all the non-last tokens? I don't know the answer to this. And maybe we'll have to figure it out empirically by just trying stuff. All right, does einsum have a bug? Yes, we found a bug last time in einsum. I've since confirmed that it is a bug. So we're just not going to use it the way that we were trying to use it. Why is it so slow? I don't exactly know the answer to this. I can say that I let it run for 55 minutes and it never finished an epoch. When I tried to do a prompt, it didn't work, but that's also because I haven't adjusted the output to care about the multiple tokens. The other thing I noticed was that I was not using my full CPU. So I don't know yet why it was so slow. We'll probably have to figure that out today. Am I right to predict that it's am I right that it's learning to always predict the same letter? I was hoping to be able to confirm that after training was finished, but training is not finished, so I don't know the answer yet. I think the answer is probably yes, because I don't have attention, so each example, each letter basically needs to, what am I trying to say? It was only able to see one letter while it was making its prediction. Okay, so what's our agenda for right now? We're basically just going to try to fix a bunch of stuff and then see where that gets us. So I want to fix the way that we're training so that we use all of the pieces of the input or of the output. And then I want to get it to actually work, and then we'll revisit what, and by actually work, I mean, it's not going to do better than before. It's only going to be able to predict one letter at a time because I haven't implemented attention yet. But I want it to like be able to run and to use my CPU and then finish and then be able to make a prediction, even if the prediction is not good. So that's our goal for today. Let's get started. So the first thing is, we need to change the shape of our training examples. We're not predicting a single character. We're predicting a list of characters. So inputs and outputs should both be the same number of tokens. So the input is the letters from I to I plus characters. The output, instead of just being the letter that comes after, is going to be I plus 1 to I plus characters plus 1. So it's the same text shifted to the right. It's this. If this is the input, this is the output. So this is a tensor. And that should work because I'm using the same method on both of them. Then Then I think that might be all we need to do, because now this should just work, I would think. Why don't we print the shapes? I expect these both to be 3D tensors. 87 by 10 by 50 is the shapes that I expect for both of them. We haven't printed anything. Isn't that weird? What are we actually doing right now if the progress bar is started but we haven't printed anything? Oh, we haven't even, I forgot we had this print statement here and this didn't get printed either. So we're still doing the forward propagation? How can that possibly take so long? We're doing the forward propagation for the first batch right now? How's my CPU doing? It's not really in use. So what's actually happening right now? Let's kill that. Obviously it didn't do a single round of training, so that's not going to work. And I'm guessing that's what was happening before. I guess I'll just put some print statements and try to find out where we get stuck. Print before update batch. Print after update batch. I'm guessing it's failing in the first update batch. So we got to before update batch, but we're not getting to after update batch. Print before backprop. Print after backprop. Kill this. So we are getting stuck here somehow. So how about we print about to do layer. So it's failing on the very first layer norm. Here's what I'm curious about. One of the many things. So let's stop that. I'm curious if one of the tensors were 1, shouldn't this work the same as before? So if we're doing one character, we're getting stuck in the layer norm still. What if we just did 10 characters in one batch? Because now it's basically a matrix input. Still having trouble at the layer norm. So what's going on in layer norm that could... don't tell me I'm in an infinite loop here somehow. Is that for real? Print self dot gamma dot shape. Okay, I'm in an infinite loop. And the shape is not growing, so this is not working properly. NumPy add new axis. Because I don't have a comma. But do I need to... I don't know if I would need a colon for as many axes as I have. Because I might need to do this instead. np.expand dims of this. Add the new dim in the last slot. So I think that worked now, and I think maybe we have a different error now. Yeah, now we're in the linear layer. Linear. And it doesn't like this matrix multiplication. Print self.weights.shape x.shape self.biases.shape. I'm guessing I need to do the same thing, add the extra dimensions to the, at least to the weights. (64 by 87). That makes sense. 64 is the output dimension, 87 is the input dimension. This is my tensor. And then the bias is 64, 1. The output of this is going to be 64, 10. And this I wanted to broadcast. Although actually the output of this was going to be 64, 10, 1. So I might need to do this same stupid thing on... I thought I tested this and you don't need to do it. Did I not? NumPy matrix multiply different size tensors. Attempting to matmul the last two dimensions, but I actually want to matmul the first two dimensions. I don't know. I thought I tested this, but I guess I have to try again. Python import numpy as np, or let me do it in a file here so I can paste it more than once. Import numpy as np, numpy dot array 1 2 3 would do a 2D tensor or a 2D matrix. So let's just do 1 2 comma 1 2. Call that W. We'll say X is an order 3 tensor, so 1 2 1 2 3 4 3 4. W dot shape X dot shape, and then result equals W dot or at X I'll just do this. Yeah, what am I doing? Okay. So at least the shapes work out the right way. Let's make them not the same size. Which would mean I need an extra one of these. And then what if I didn't have, so what if it was by 1? Wait, I meant to make, which axis did I mean to make be a 1? I guess it would be this one. So W is this, X is this. W multiplied by X. This is with a batch size of 1. Okay. So why is this not working as intended? Because my tests, I thought the thing I just tested would prove that this should work. Um, ten is different from 87, and the sizes are 64, 87, 87, 10, 1. But shouldn't that work? Shouldn't this give a 64 by 10 by 1 result? Size 10 is different from 87 in its dimension 0. 10 is not the 0th dimension on either of these. I'm confused. Oh, wait. 23231. But I have the equivalent of what I have is 23321. So it's just confusing to me. What does shouldn't it be n by m multiplied by m by n? Just having trouble even understanding the... Okay, let me just make... Let's comment this out. Let's just say w equals numpy dot ones of this shape, and the shape is going to be 64, 87, x is going to be 87, 10. So that works. But then if I added an extra 1 on the end here, that stops working. What if I added an extra 1 on the end here? That's still not working. This is where I need an einsum to be specific about what I'm trying to do. I was hoping I wouldn't need to do that so that it could be easier to read, because this is like so easy to tell what's happening. So how does NumPy matrix multiplication on tensors, what does it do? It treats the last 2 dimensions as matrices. Oh, that's annoying because my matrices I need the first 2 dimensions just because of the way I've laid things out. Okay, well, let's move to einsum, I guess. Close that. Don't save this. Comment this out. And return np.einsum self.weights x. Actually, you can't return that because I then need to add, well, yeah, you can just need to add plus self.biases. And then the sum is nm, etc., mn, etc., goes to, or wait, let's just do ij, jk, goes to ik, etc. I think that's what I want. I added an extra, yes. Okay, here it's just having trouble adding the bias, which I thought was being broadcast properly, but I guess I need to reshape it. It's not the shape of X though, is it? It's the shape of of the thing that comes before it, which I don't have a value for yet. Matmul equals this. Matmul plus that. Or dot shape. Also interesting that I already have the 1 here. But why do you think biases is an array? Because if I print, you know that it's 64, 1. Okay. So just, I guess I'll do the stupid while thing again. Where were we? Right here. I hate it. What's the problem now? Oh, new problem. Now we're in softmax. Okay. This is just matrix multiplication over the first 2 indices. I don't need to write that, that's obvious. This was our bug in NumPy. We'll just delete that. Okay, so we're at softmax. We've got a new error. Input operand 1. No, we're not at softmax. Even though softmax is the last thing we printed, we were about to do. Oh, maybe we've... Where's the error? Update batch. Backwards. Oh, we finished the forwards passes and now we're doing the backwards passes. So no, I guess I would have expected to see after expected to, oh, I guess we probably are seeing this. So here's the shapes of the activations all the way through. At the end, we have 87, 10, 1. So we have the same shape for our our output activation and our label, which is perfect. And then oh, I see. So we changed the way that we changed away from doing matrix multiplication in the forwards pass of linear, and now we have to do the same thing in the backwards pass. So can't use matrix multiplication anymore. Gotta switch to einsum. NumPy.einsum. So I think you basically go backwards. So you say IK is the output. I don't think I need to transpose anything. I think I just say IKJK goes to IJ, but I'm not sure. The weights are the thing that are the same. IK is the output. Well, no. Yes, actually, I think that's right. So IJ, IK goes to JK. And then D comma A okay, I think I can just do this the other way. I can just let me just do this by doing the definition of a matrix multiplication. So just this. because we know that works. And then if I wanted to get rid of the transpose, I could just do ji here. So let's do that. And then here I do kj. Where's the error now? This is just a broadcasting issue in the optimizer. So this, at least this has the right dimensions. I don't know if it's correct yet. Optimizer. So that makes sense actually. So I need to do something like this. Dot reshape param dot shape. Okay, something is happening. With a batch size of 1, this should be fast. It should be about the same speed as before. What's the deal though? What is it doing right now? Is it using my CPU? No. Did we find a new infinite loop? Oh. Well, that's weird. It's doing something, but it's not using my CPU. Why would it not be using my CPU? All right, it printed stuff, but it printed so much stuff that I couldn't see. The progress bar, if there was one. So I'm gonna kill. Okay, we did an epoch in 3 minutes. I'm gonna say hello. Oh, yeah, that makes sense. So I still haven't updated the part that the autoregressive part. So we vectorize a prompt. Which should be a 2D. It's like a face of a matrix. It's this face of this tensor. This isn't a real thing. I'm gonna delete this. So I think this makes sense. It'll be a tensor of a smaller size than elsewhere, than in the training. Weights is going to be a what's weights going to be? It's the softmax output but there's going to be one per sequence, per token in the sequence. So I think this is 2D, but we're expecting it to be 1D. But I only care about the last one. So here I can just say if weights dot shape, if it's greater than 1, let's do while weights, just do if. Then I want the last one. So weights equals that. So if, what's the right way to say this? If I predicted every token, every intermediate token, just take the last one. If I predicted one token per input token, just take the last one. Is that possible that that's what I mean? And it's weird that this doesn't use my full CPU and it takes 3 minutes. What is it doing if it's not using my CPU? I need to profile this. I am not even sure what it could conceivably be doing. Like, how can it be doing I/O? Now, it takes a really long time to do the validation. By the way, am I using test and validation data? What am I using them both for? I use the validation data for the learning scheduler. And then I use the test data for the just to print. So that's pretty inefficient. 0%. That's crazy. Our validate must not be working properly. So let's kill this. That's doing something. Why is it still going? Why did it print so much stuff? Oh, I'm doing 1,000 characters. Well, this shows me that it didn't learn anything because it's printing really rare characters. But I guess why would we expect it to learn anything? I don't think we would. I mean, I guess I would have expected it to print a non-rare character at least, but I wouldn't expect it to print anything that makes sense. If I switch to the old way of doing it, where you have to do times cars. How bad have I broken it? I have batch size equals 1. So this should be really fast, but it's not. Something else I'm going to do is I'm going to use constant schedule. I don't need a difference between validation and test data. So I'm just going to remove the concept of validation data. Okay, and then no such thing as validation data. Let's go into here. No such thing as validation. Training data can be 85% of the data. And then you have to update more than just the comment. And let's do the same over here. No such thing as validation. 85, 85. And for MNIST also. I guess you might as well use a decay schedule if I'm going to be calculating it anyway. This is crazy though. How did I make it so slow? I don't know. Is it just using einsum instead of matmul? Oh, actually, having a smaller batch size makes it slower, not faster, now that I think of it. It makes each individual thing faster, but... Although, I guess it was only like a 2 times speed up, I thought. But what are we actually doing if we're not using the CPU? I actually have to learn to profile. Python profiler. The validation itself is taking so long. Which means it's just the forward pass that's taking so long. %, after 7 minutes. All right, so I totally broke everything. I can do it from the command line. Python-m c profile main.py. But yeah, this is what I want. Just .run, or it's not even .run. It's C profiler. .profile. Profiler.enable. Do this outside here. And then if I kill this, what is it gonna? It didn't output. Okay, so let's not do it from the command line. Profile enable, and then out here. Why is this indented? Oh. And then out here, profiler.disable. Stats equals pstats dot stats stats dot sort stats cumulative. Okay. What are you doing? I want to let it run for a few more seconds so that the time isn't dominated by the load. Oh, no, wait, I only started profiling after loading, so let's just kill it here. And then what does it say? Train, update batch, validate. So just going forwards in the apply during validation is taking a really long time. Doing update inside the optimizers is taking a really long time. We only called validate once. We called apply 362 times. And we called update 90,000 times. We're spending 6 seconds in einsum. But each call is really fast. I guess I'm also curious about the difference between CPU time and wall time. What does tot time mean? C profiler tot time. Oh, okay, in the function alone. So I'm doing something slow in optimizers.py that's not because I'm calling something slow. Oh, we can see the different forward and backward things. It's pretty well spread out between them. 86 is the slowest one. Line 86, which I'm guessing is linear. No, it's layer norm. This is the slow one. That's interesting. I'm not really doing anything that could be slow except for maybe this while loop somehow can be slow. Optimizers line 46. Which is just update. This math is really slow. I don't know if I can do anything about that. Huh. I don't know. I want to... Let's let it run for a whole epoch. And then I wonder if I should revert all my changes and see what it used to be. Actually, sorry, I'm gonna kill this. I'm gonna make the batch size back to 50. So that it's more similar to what it was before. Oh. There's not supposed to be an 870. So something is not working. In layer norm. Print self dot gamma dot shape self dot beta dot shape. Should be 87,150 or maybe 8750. Probably just 8750. 870. Where is that coming from? Oh, the first layer norm actually is 870. Because it's 10 characters. I forgot about that. And then we're going 1, 1. But why are we... Why is our input a order 3 tensor? Because aren't I loading the... Yeah, I'm loading the old way of doing it. Um, okay, so why does my input look like that? Um, let's do that thing where we print the sizes of all the activations. Print x.shape for x in x's. $870, $150. So where's the 1 coming from? Where's that 1 coming from? Print data.training 0 dot shape. What does the first training example look like? Oh, that's a pair, and then what is the input and what is the output? $870 by 1, 87 by 1. So I think I used to do the by 1 thing because I didn't used to handle inputs of arbitrary sizes. But I don't need to do that anymore. Vectorize. I shouldn't need to do that. Layers, print. Okay. Still can't. Still not working. So what's going on? First of all, how's my CPU? Once it starts training. Still not being used. Um, all the time spent in training. Apply. When is apply? Where does apply come from? Is apply only called in validation? Apply is only called in validation. During the backpropagation, we do our own forward, we call forward for each layer. So we're spending most of our time in apply. We're also spending a lot of time waiting. I don't know how to read this though. Update batch is not spending a lot of time at all. All the time's being spent in apply. How is that possible that we're spending a total of 1 second in update batch and 30 seconds in einsum? So most of our einsum work is going into the validation? It doesn't make sense. So we should do a whole epoch before we validate once. And it's not like validate is doing anything that different. I guess I need an axis on this. How does the argmax axis work? So this would be 0. What's the default? Is the default 0? Oh, that doesn't make any sense. This should be... zero. I don't think that'll fix anything, but... Well, actually, it might fix the percentages. And then... this needs the same thing. Why is this broken? Decode is broken. Or maybe it's not, maybe decode's not broken, but I'm getting a number that's not in the range, which means my softmax is broken. Out here. Well, this doesn't... I don't know what this will do. I don't know if this returns a 2D thing. Print weights.shape. Let's find out. Okay. Don't clear because we've got this profiler information. Is my CPU being used now? No. I didn't change anything that would make it be used. What did I change? I don't remember. Oh, the argmax axis. Why am I doing an argmax on the expected output? I guess it should already be argmaxed. Shouldn't I just do Y here? No, this will give me a number for each column. Okay. This is taking a really long time. And then it failed. Because my validation's not working. Okay, can I make this take way less time just so I can... get stuff done? 10 examples per epoch. Good. So... validation is not the right... validation's supposed to just be a number. But it's an array. Oh, because the equals equals is probably being broadcast. Okay. NumPy compare arrays. np.array equal. Well, you know what, actually? Come to think of it, I don't want the arrays to be equal. I can do an element-wise comparison. Why are there so many, though? There should only be... I don't know how many there should be. Print expected.shape, actual.shape. Expected is just a number. Which makes sense when we've got a single character vector as output. Actual is a vector, which is unexpected. The thing that it's argmaxing, what does that look like? Um, 87 by 870. Well, it shouldn't be by 870. That doesn't make sense. There's just supposed to be 87. Oh, the batch is... Something is messed up. Let's go back to batch size of 1. So it's got nothing to do with the batch size. The final activation should be 87 by 1. So is there something broken in my softmax? Why don't we go back to network to apply. Print. X.shape. So let's trace the activation through the network. 870 by nothing, which makes sense. The activation's 870 by nothing, and then we get it to 870 by 870, which is wrong. It should still be 870 by nothing. So what's going on in layer norm? And then it kept this extra dimension the whole way through. So something's rotten in the state of layer norm forward. Is it because we're adding dimensions? How about right at the end, print self.gamma.shape, x hat.shape, self.beta.shape, and then just exit. It shouldn't be 870 by 1. It should just be 870 by nothing. No. It's okay to be by 1 because we... Well, where is 10 coming from? Where's 10 coming from? It should be... Batch size is 50. Where is 10 coming from? Why is the input 870 by 10? Is it because... It's because we only have 10. I'm stupido. I am stupido. It's because we only have 10 samples total. So let's make that 100. Just so that we can have 2 batches. Okay. And obviously I meant to put this in parentheses and add a dot shape on the end. So the output of the forward is the right shape. So what's going on here? 870 by nothing. Wait, now the output's the wrong shape. Hold on. So what's going on? So this looks right. But then this is wrong. How did we... Oh... Okay, I understand, and it's insane. It's because we're reshaping... Okay. It's because we're reshaping the gamma during the backwards pass to have the dimension of the batch, and then when we go do the forwards pass, it has too many dimensions. So it adds the dimensions to the outputs. I explained that poorly, but I hate this. This is basically like I need to do gamma equals self dot. No, I don't want to make a copy because that's going to cost a lot. I just want to forget the extra zero, the extra ones when I'm doing inference. The other way to do it is to add the dimensions to the x vector. That's so stupid, though. Like, I think this will fix it, but I don't like it. Okay. Unfortunately, I have to go, which is a shame because I didn't really accomplish anything. Like, this is in progress. This is in progress. And I mostly just broke stuff. But I do have to go now, so that has to be it for today. Thanks for watching.